quite easily. I appreciate that. But one thing which I didn't quite get my head around, and I think that's probably me, but as a non-mathematician, but possibly quite a few other people in the room feel the same way, is this new method you've come up with. Is it only useful if you're dealing with an existing model where you have an idea of what the full space looks like? Is it a tool for dealing with model outputs to try to better understand why you're getting models? Or is it equally applicable if you were dealing, let's say, I don't know, you had a whack of data, a bunch of predictors, a response, you built some kind of mixed model, statistical model, and then you had some level of uncertainty. Would it be applicable then? Because then to me it seems that you don't quite know, you risk throwing out stuff that you don't quite understand why you're getting it in a way that you would if you were working with a model. If that makes any sense.
Yeah, I think so. Yeah, thanks for the compliment, by the way.
You're welcome.
I wonder if it meant that there wasn't much content, but
Possibly.
there we are. Yeah, it's really for... I'm thinking about situations where we have models and we're comparing them to observations that definitely didn't come from the models. And that the problem that we believe we solved in the particular cases I highlighted is really one of the problems that arises when you think carefully about bridging that gap. Your example, you were talking about data from the real world and trying to infer other things about the real world from that. And yes, issues might happen if you use a model that is incapable of giving you the right answer. So if there's a very strong relationship between some variable and what you're seeing, and you forget to put that variable in your model, then it would be a similar feature, but the method we have is purely for computational models.
Thank you.
Great, thank you. No one else wants to respond? Yeah, lady at the back.
I was interested in, Chris, your talk about energy infrastructure and uncertainties there, but I wonder whether there are also things how to deal with uncertainties with development in technologies. So there's lots of unknowns, but also limits of the physical infrastructure as well. So for example, when you look at Northeast blackout in 2003, it's quite complex. Everything is connected to each other, and there are cascading failures, and we are at the end we have a live, I mean, energy infrastructure or electricity is similar to ecosystem. It's just dynamic and response, and there are lots of impacts and voltages and regulation and this and that.
Yeah.
So
Yeah, I think they're both again two issues which are one level energy issues, but raise much broader questions. I mean, the technology one, I mean, it's quite obvious, I guess, to this audience where issues lie. That it's as you say, it's the things that haven't been invented yet, and I would class this again as one of these points that isn't addressed head on in analysis always, because it's very easy to end up doing some kind of bottom-up system modelling and inventing spurious detail about. I remember seeing one plot associated with the potential market for chicken feces in the 2030s or something like that, sort of system modelling of markets for products that don't exist yet is speculative. So that's I think that important, and that could be I mean, that could be another interesting topic for discussion in the programme. Don't really have any answers. The cascading blackouts. I mean, one feature of the big cascading blackout events where you see 50 million people or however many without electricity. One feature of these is that they, if you look at the causes of each individual one, it will be something quite unusual and sort of buried deep in the really fine detail of how power systems work. And the one thing you can be pretty certain of about the next one is that it'll be very different from the last one. So again, that so attempting to get at that's a case again for different reasons where attempting to get at an understanding of these by bottom-up modelling is challenging, and certainly trying to make some sort of overall risk assessment through detailed bottom-up system modelling is challenging, because unusually it's not just that fine detail matters, it's that it's absolutely fundamental to these events. There have been various, I think quite successful attempts in looking at the overall matters like the overall distribution of blackout sizes in a given electricity interconnection, and this is a little bit in analogy to how it's very hard to predict, or there's little ability to predict when the next earthquake will come in a given region, but the distribution of magnitudes of earthquakes tends to follow a pretty well-defined power law distribution in given regions. So things like that can be done. Possibly again, there are some analogies to be drawn. I mean, I think they're looking. I think they're. Sorry, one other thing. I did actually see a very, very nice piece of work by one of Martine's colleagues at Warwick, Simon French, where they were looking at getting at the risk assessments of these by a sort of top-down elicitation process about how likely all the different stages in the chain are, and how long restoration times might be for getting the system back up and running again. So I think that's a case where well, I guess this tends to be my answer to everything, that quite often current research tends to be about bottom-up system modelling, and we ought also to explore the how more top-down approaches, probably through eliciting problem structure from experts, might operate.
Okay, great. We'll move to another question. So I think we've got Nick and then Tom.
So, Danny, I really liked your XKCD counting. I thought that was brilliant. And I really liked your example of the 33% uncertainty versus unlikely versus unlikely 33%. I think these both speak to your question of what is uncertainty. I think is an extremely deep question. I think it's an extremely challenging question, and I think it's one we probably need philosophers in the room to have a conversation about. I think it's, the sort of nested error bars is actually a really good point, because quite often we want to know what the uncertainty on a perceived measure of uncertainty is. In exactly the case for 33% unlikely, what you really want to know is, how certain are you that it's 33%? What's the error bar on it? Right? So I don't really have any solutions for communicating that, or really any solutions for how we do a better job of measuring it. I think it's worth studying, and I'd be interested in peer-based conversations about that.
Yeah, I mean, I haven't really got anything to add to what you said. I agree with all of it. I think I had one other example on that slide. I don't know if it was anecdotal, but I was told by a stakeholder that somebody had provided them with a flood map in the past, which said their location was unlikely to flood, but that was made with high uncertainty, and how they were meant to interpret that was beyond me. But yeah, that is a major challenge for us when we are talking directly to stakeholders, and it's not one we've properly got our heads around.
It's a challenge for us to understand before we can even communicate it to other people. Right? We have to understand it.
One way to view that cartoon is actually as mocking the idea that we should have error bars on error bars, and you might be right about needing philosophers. There are various ways of formulating probability, and in at least two of them, it doesn't make sense to be uncertain about a probability. You're supposed to kind of integrate all of that together. And yet we live in a world where we have the IPCC, and we have this sort of idea that we produce an uncertainty assessment and then we put a confidence along with it, and So it's highly likely that this thing will happen with 50% chance, and you can flip yourself around quite a lot. Yeah, bring some philosophers. That'll be. Have we got any coming?
Okay, cool. We've almost got some more questions. So
Yeah. Well,
can you maybe just? I'm just thinking there's a lot of questions left, so let's just gather a couple more, and then you can maybe integrate your answer into it. So Tom.
So I had just a question about model refinement, data-driven model refinement, and I think I really enjoyed hearing about the emulation approaches, and it's hugely impressive. But I think with where the field is in terms of land use decision modeling, in many cases, just even basic model calibration and validation is not done. I can send you links to about 10 models out there where that's not been done at all, and yet people are suggesting that these models are used in decision making. So I think there's a real question about what are the data, what are we trying to model? And obviously we can get philosophical. We're trying to model sort of desired societal outcomes. We do need philosophers and ethicists, here, because that's a can of worms in itself. But in a land use system, we're talking about ecosystem services, I guess. Some things we've got data on: timber production, agricultural yield. But in many cases, recreation, pollination. We don't really have good measures of what we're actually trying to model. So there's a big job in gathering those data together for a start, but also those data have uncertainty, because we're going to measure a proxy. We're not going to measure the pollination service to every plant. We're going to measure number of bees or hoverflies. So we're measuring a proxy. So there's uncertainty in that proxy, and the question is, how do we combine that uncertainty in the proxy with the structural and parameter uncertainty in the models? And I think there's an area there to think about. We can't take the output, the data as a kind of gold standard, because there's lots of uncertainty in that as well.
I'll just say you did mention philosophy, so I'd say, yes, definitely there are lots of very good practical, well, not lots, but there are very, very good practical applied philosophers around. In fact, when we had there was a panel at the Models to Decisions conference, which was co-organised by a philosopher, and we had a different philosopher on the panel. So these people do exist and are very good people to be involved with. Just one comment on the understanding of probability. That I think it's one of these. Understanding of uncertainty. I think it's one of these terms where you simply have to define on a case-by-case basis. There's never going to be a universally accepted definition. So you have to explain what you mean by it, and you have to ask other people what they mean by it. And probably when you ask other people, they just start getting a bit nervous.
Yeah. Again, I kind of agreed with what you said and the complexity of it. We do have a lot of pressure in the other direction. Obviously, we need to validate our models, but when we're using sort of proxies of happiness and things, stakeholders want definitive decisions. It's traffic. They want traffic lights, and so. Whilst I agree with you, we do get a pressure in the other direction to be as simple as possible and tell them, yes, it's worked, no, it hasn't, or a very small gap in between. And it's hard to further complicate the discussion by asking whether our measure of happiness is a decent measure.
I just hope that the month is going to be about bringing people together to try and answer those questions. Because you mentioned you would need the expertise of a few people there, particularly people who understand all of the types of modelling you're doing and the social and land use context, as well as people who have experience of uncertainty quantification from different sources, maybe from other fields or statisticians. I'm kind of hoping that's what this whole month's going to be about. So yeah. That's the right stuff.
We have at least 4 more questions to go. So hi, Kate.
Thank you. Yes, the concept of uncertainty is quite often not very well defined. When you see how different people use the word uncertainty, they don't always define what is included in the uncertainty. Whether it includes structural uncertainty, whether it includes uncertainty in the input data you might be using, uncertainties in whatever form, including semantic uncertainties about the categories you use and the language you use. So my question is this: as a community of landscape researchers, do we have a concept or some principles for what we should be considering within the uncertainty assessment for landscape scale type of studies? And if we don't, should we have one? Should we have a set of principles or good practice guidance of some sort where we are reflecting on the particular issues about uncertainties in landscape data, which are characterized by multidimensional, multitemporal, spatial data, and the multiple correlations that are involved in them.
I think someone from the landscape community should answer that.
I don't think I'm in the landscape.
I'm just to take a slightly different tack on it. I mean, from a different sense of what we mean by sources of uncertainty, I find that the slide I nicked from Michael Goldstein useful from a if you like, more from a statistical perspective as a taxonomy of sources of uncertainty, and from that perspective, in principle, if we want a total uncertainty analysis, we should be looking at all of these. It's an enormous job, and it's probably never done in practice. It's possible it's never done in the research community, and I think having the best sort of pragmatic approach that we can use in practice is something we may well talk about this month.
Okay, great. So Marcel?
I was just curious about the word benchmarking in the title of this session, what it actually means. Is it comparing model outputs to some standard data sets? Is that the idea behind the word benchmarking? And if yes, are there such standard data sets? So what was the panel's idea when they were thinking about this session and were thinking about the term benchmarking?
Well, I suppose as a fairly mainstream academic, when I was invited to speak, I didn't really think that hard about the title of the session. I mean, I guess I interpreted it, what the session was about as being about how we apply good scientific process and what is good practice in thinking about modelling. If I thought about the topic of the session, it was probably that.
Yeah. So again, I didn't think too much about the word benchmark. In my defence, I submitted an abstract and got put in this session, so not my fault. But I mean, we do try and do some benchmarking on our models in a sort of sense check, and basically particularly our 3D geological models, just seeing if that what we're saying could have arisen. Are there any contradictions in there? Is it contradicting information we've got in other data sets? That's probably as far as we go in that direction.
Well, so when you work on the same corridor as one of the workshop organisers, the danger is they come into your office and say, so no one will agree to speak in this session. Will you do something on emulators? So they didn't mention benchmarking to me when I failed to put my title in before the deadline.
Okay, well, I think we're getting lots of topics to bring into the programme, but I know Martine's been waiting a lot at the back.
Hi. So I'm going back to communication of uncertainty, and this is a comment, not a question. I'm part of a group called Analysis Under Uncertainty for Decision Makers, and we have a visualization catalogue. We were lucky enough to win some money via the Turing for a project, and we did a project where we brought together psychologists and graphic designers, digital humanities, games concept designers, and mathematicians. And so the second edition of the catalogue, visualization catalogue, which is freely available on the website, will be including a huge literature search that we did all through the psychology literature of all the things that are known about how you should visualize uncertainty, for whom, etc. So lots of examples there that you might find useful, possibly.
Okay.
Yeah. Just one brief comment. Yes, that's. Yeah, that's yes. Thoroughly agree with the importance of that. Just and one thing I often think about when we do, because most of what I end up doing either involves complex situations or rare events, and in both those circumstances, you tend to end up with for one reason or another, the evidence may be expressed, or the model outputs may come with relatively low confidence. And I think how we do communication in those circumstances, when for one reason or another, whether it's very limited data or very complex situation, when conclusions come with relatively low confidence, that's an interesting one.
So I'll just there's suddenly lots of hands going up. I'm not sure we're going to get them all, but we'll quickly pick a couple off. So I know you've been waiting a long time.
Yeah, so
yes.
connecting to that, a remark on communication was in the audience that I wouldn't wait with communication until you have the near perfect answer. In trying to set up communication, you actually learn a lot, and sometimes about the science. So I made for outreach purposes only a flood demonstrator or rare event flood and rainfall demonstrator. I'm still surprised how many spin-offs there are. Now going to validation and benchmarking, that's Ben, for a question for Ben. Are laboratory models used where you kind of do blind setups, where you drill a borehole and from that test what's happening? Because then you have full control, right? You can see what you have and you can test your models. So again, in this setup, I did this demonstrator. I by accident had a groundwater cell, and I put in a configuration just while hands shuffling, which could not be modeled by grid to grid, which was rather amusing, I thought. So our laboratory models used to validate those 3D models you said you have only very sparse data for. But that's benchmarking, right?
Yeah. Where that happens more often tends to be that someone else has dug a borehole, and we see if that's consistent with what our model says. Because most of these boreholes, they're not ours, but people are obliged to give us the information a certain number of years after they've dug it.
But I'm saying that laboratory situations could actually provide you a lot of more benchmarking for your modeling.
To be honest, I'm not massively involved in the validation of those models. I mean, certainly on the soils ones, we'd be doing simple things of leaving out checks, of leaving out data, and then bringing them back in purely for validation sets. And they're actually very good on those models of all these sort of correct replicate sampling, randomized orders for doing analyses, and taking internationally samples from elsewhere where the answers are known. But yeah.
Right. Okay, just very last question from the gentleman there.
Just returning to the issue of uncertainty and trying to convey it to policymakers, who I think some of the results you showed there say they find it very difficult to handle that. Whether something else we might think about as a group is how we advise in making those decisions under uncertainty. So not trying to pass this problem on to them, but trying to help them in solving those decisions under uncertainty. And in the landscape world, we're talking about making decisions here, in which we're going to have these heterogeneous landscapes with different sites of use on them across all different areas. And the obvious parallel is the way in which we make decisions about investing in portfolios of assets in the economics world. I've already declared myself an economist, this is it. So I wonder whether that's another area we could focus on, is thinking about how do we make that decision process under uncertainty easier. How do we think about developing landscapes which protect us against different possible outcomes, different states of the world, given our understanding of uncertainty? So rather than just passing the uncertainty over and say, you make a decision now, really difficult to do. So, well, how do we actually help them, given these structural uncertainties, come to decisions which are robust against different possible outcomes of the world?
Yeah, I mean, I haven't too much to say on that, but the amount we push in that direction is we kind of try and provide the end user with scenarios of what will happen under the different decisions. But our models tend to be looking at one thing in isolation, so that's not really answering your question. So.
Yeah, I really don't think we have a decision theory anymore for the modern world of 20 different algorithms that say different things about the same data, that with complexity. It's something for us to work on, and I agree. But there was also that point you made about decision makers finding it really hard to understand uncertainty. And I always think if I went down the pub back home, so I grew up near Hull, everybody in there on a Saturday would be talking about various horse races they were about to bet on. They have a very good understanding of odds, and they make decisions under uncertainty, and they communicate about uncertainty in that way. And these aren't, maybe didn't finish school, maybe did, but they're not trained policy people in that sense. I think we don't give enough credit to policymakers in some sense. I think they probably can handle uncertainty.
Did they make good decisions? Your friends in the pub?
I don't know.
That's the point, isn't it?
That's probably subjective. Huh?
We're trying to provide them with the tools to make those decisions more robust.
Okay, Chris, do you want the very last word before we break for lunch?
Yeah, I think how we, as I've probably hinted before, how we bring the technical modelling together with the practical decision processes is a subject of research in its own right. I mean, when I've been involved, when Stan and I have been involved in the electricity security of supply work, we think about this a little bit when. There are some people like Jim Smith and Martine Barons and Simon French at Warwick who kind of bring together thinking about practical decision processes and the technical modelling in if you like in one brain. Then there are other projects which kind of try to bring together people from different disciplines to think together about these processes. But that is perhaps also goes back to a comment that Gavin made, that one of that obviously we can make further technical advances in modelling, but with a lot of things in terms of their practical relevance, we really don't yet know at all how to get people using them in the real world, and therefore the most important thing in terms of getting them used in practice is not having even smarter models in the research community. It's about how we actually integrate them into these practical processes.
Brilliant. Okay, so on that note, can you please join me in thanks for